Hi everyone, in this video we will be focusing on logarithmic concentration relationship. So we will be focusing on finding the molar concentration given the p-value of an element. So if you have seen the previous video, we have discussed how to find the p-value given the molar concentration. So in this video, this would be like an opposite manner of calculating. So just a recap, okay? Finding px or the p-value, right? Px is just a negative logarithm of x, okay? Where this x is the molar concentration. Concentration, right? So this is how to find px. But what if we were given the px and we want to find x, right? So we can do this, right? Px, let's multiply both sides by -1. So to cancel this, so we will get negative px log of x. Now, we want to cancel this log in order for us to isolate x. So this would be the molar concentration, right? And in order for us to cancel this log function, we have what we call anti-log. Anti-log is basically 10 to the power of something. And this one, let's do this on both sides, okay? So 10 to the negative e of x is equals to 10 to the log of x. Okay, so basically 10 to the power is an anti-log. So meaning this would be cancelled. Okay, leaving us with x. Thus, finding the molar concentration or x is simply 10 to the negative dx is equals to x. Okay, this will be the formula that we will be following during this problem walkthrough because we will be solving three problems following the same principle. Okay, so I have here the fundamentals or the basic formulas that we can picture in these problems. Okay, this is what we have solved. So concentration or the molar concentration of X is equals to the 10 to the power of negative px, since this one is in negative log form. So if you want a more detailed discussion about the p-value or finding the p-value, we have a more detailed discussion, so we can find this in the link above. So just check it out. Okay, let's start with number one. Calculate the molar concentration of Ag plus in a solution that has a PAG of 6.372. So this type of questions are very straightforward. Okay, we want to find the molar concentration. So this is the X with the given P value. So PAG meaning the P value of silver ion or the Ag plus. Okay, solution. Okay, so let's find concentration of Ag or Ag plus or silver ion. Okay, this is the X in this case. Okay, so that would be 10 to the negative Px. So our Px is Pag, which is 6.372. 6.372. Okay, and we can use our calculator, and that would be 4.25 times 10 to the negative 7. Okay, so that's easy. So this is in molarity unit. Okay, it's very easy, right? So that's how you find molar concentration with the given p-value. So it's a very straightforward solution. Just remember, x is equals to 10 to the negative px. while finding the p-value or px is equal to negative log of x. So it's either the molar concentration is given or the p-value is given. Okay, so let's head to the next question. Okay. Number 2, calculate the molar concentration of copper 2 plus in solution that has a PCU of 5.48. Okay, so this is our x. We want to find the concentration of this. Okay, so the concentration of Cu2 plus. And given the Px or the PCU, which is 5.48. Okay, if you remember the formula, the concentration of copper 2 plus is equal to 10 to the power of negative PCU, which is 5.48. And calculating, that would be 3.3 times 10 to the negative 6. So this 6. And it's in molarity unit. Okay, so that's easy. Next question. A solution has a ppb of 7.15. Determine the molar concentration of Pb2 plus in the solution. Okay, so we're given the p-value. This is our px, 7.15. We need to identify or to determine the molar concentration of Pb2 plus. So this is our x, or concentration of Pb2 plus. Okay, so following the formula, concentration of Pb2 plus is equals to 10 to the negative P of x, which is 7.15, equal to 7.1 times 10 to the negative 8 molarity. Okay, that's it. It's very easy. It's a very straightforward problem. So that's all. Thank you for watching, and goodbye.